in number 3, we were looking at answering probability questions where you are given some values and you're asked a probability. This time we're going to be asked them in reverse. You take a population as a mean, a standard deviation, and we are asked to find the value below which the smallest 10% of values lie. If we take our normal curve, the mean would be here, it's 23. Each of these bars represents one standard deviation of 8. So our value that we're trying to find is this line here. It's one of the standard deviations from the mean, such that the smallest 10% lie under it. So we take our graphics calculator, we go to stats, distributions and normal, but this time instead of using the cumulative distribution we use inverse normal, which allows us to find a range from our probability. Now it's asking us which way the tail goes. Our tail in this case is to the left, so we leave the tail on left. Our area is 0.1 because that's 10%. So we take 0.1 area, 10%. Our standard deviation is 8. Our mean is 23. And when we execute, we find the value of 12.747, 12.75 rounded. So that is the value below which 10% of this population lies. It is 1 and a bit standard deviations from the mean, as we expect, and that's a number, not a probability. We'll try again. In context, fish in a lake with a mean weight and a standard deviation. The fisherman only wants to keep the heaviest quarter, so what weight should he keep? We have our mean, we have our standard deviation. We want the value so that the highest point is 25%. If we visualize that, we get a fitted curve, and we want this. We want the 25% to the right. So my calculator will make the tail right. Of course, if your calculator doesn't do it to the right, then you want the 75% mark measuring from the left. So on our calculator, mix it back up. This time our tail is to the right because we want the heaviest 25%. It's quarter, 0.25. The standard deviation, we're given that, that's 1.03, and our mean is 4.56. Execute that, and there's our answer. The heaviest quarter of the fish weigh 5.25 kilograms or more. One more time. A weight loss program gives a mean loss 4.6 kilograms, standard deviation of 3.4. It'll be interesting this time because the standard deviation is quite large compared to the mean. How much weight did the bottom 5% of the people on the program lose? We're going to calculate it, mix it up. This time we want the tail to the left because it is the lowest 5%. Our 5% is 0.05 is the area under the graph. Our standard deviation is 3.4 and our mean is 4.6. So that says that the number we are looking for is minus 0.99. So that means that the lowest 5% of this group actually put on just under 1 kilogram. What we have to remember is NCD on our calculator is for when we want to find a probability for a range. So when we have distributions, normal NCD, we are asked for 2 ranges, some values, and the output is the probability. However, when we have the probability, we use inverse normal. There we say which area we want, the standard deviation and the mean, and the result is the number that is the border for that probability. NCD for when you want to find a probability, inverse normal for when you have a probability but need to find the endpoint.